Welcome back to Systems of Equations. We are now going to look at solving using elimination, which we've been using a little bit already. We've been cheating a little bit, but that's okay. Here we're going to solve a system of equations by elimination. We have 2x plus y equals negative 3 and 3x minus 2y equals negative 8. I am now going to look at these two equations and figure out what I could multiply one of the equations by such that one of the terms would drop out. So if I look at the first equation x terms, I can see that it wouldn't be helpful to try and multiply those together because there's another term that would make this even easier to do, because we have a negative 2 in front of the y and a positive 1 in front of the other y. It would be easier just to multiply the first equation on both sides by a 2. That's what we're going to do. That gives me 4x plus 2y equals. Now I'm going to add these together. The 4x plus 3x will give me 7x. The 2y minus 2y goes to 0. And negative 6 plus negative 8 is going to be negative 14. Now if I divide both sides by 7, I solve for x. X is equal to negative 2. And that is one of the two parts of the solution done. Now I can go back to the original equation. Notice, first step, identify a factor to multiply through so one of the terms drops out. That was here. The second step is to solve for that variable that's left. 3 is to substitute that value back into either of the original equations. So it really doesn't matter. I'll go ahead and pick the 2x plus y equals negative 3. And I'm going to substitute negative 2 in for x. That gives me 2 times negative 2 plus y equals negative 3. This gives me negative 4 plus y equals negative 3. Adding 4 to both sides to solve for y gives me y equals 1. And I have now found the solution to my system using elimination. Now you might be thinking, wow, this is a lot faster than solving by graphing. And it really depends on how the system is presented to you, which one is going to be faster. I would say elimination is more precise, but you do have to practice the process. So your coordinate point where the two lines intersect would be at negative 2, 1. Let's look at example 2. We need to solve the system of equations by elimination. The system is x plus 2y equals negative 1 and negative x plus y equals 3. Looking at the system, I don't even need to find a value to multiply one of the equations by because I notice that the x term is opposite. So I'm going to just add them together, term by term. X minus x goes to 0. 2y plus y is 3y, and negative 1 plus 3 is 2. Y is equal to 2/3. Now I can just use that y value in one of the original equations. I'll go ahead and use negative x plus y equals 3, where I substitute the 2/3 in for y. This gives me negative x equals 3. Subtracting 2/3 from both sides gives me negative x equals 2.3 repeating. Now, this probably is looking familiar to you, but I want you to notice how much faster this scenario is because we're not asked to graph it. We're just asked to solve by elimination. Now we need to divide both sides by negative 1 to get rid of that negative in front of the x, and we get x is equal to, and I am partial to fractions, so here we go. It's going to be negative 7/3. So my solution in the x direction is negative 7/3. My solution in the y direction is positive 2/3. And so the coordinate point is negative 7/3, comma, 2/3. Now let's move on to the next one. We have the system of equations 2y plus x equals 8 and 2y plus x equals 2. Let's see what happens when we try and solve this system of equations. Notice that the two equations have exactly the same terms on the left-hand side. If we want to make them drop out, we would simply multiply both sides of our equation, either one of the equations, by -1. And when I do that, I get negative 2y minus x equals -2. That's the second equation. I just picked one. It really doesn't matter. So I'm going to rewrite the first equation just like it was. And now I'm going to add them together. 2y minus 2y equals 0. X minus x equals 0. And 8 minus 2 is 6. So we get 0 equals 6. And most of you will recognize that that is not a true statement. When this happens, this is a does not exist scenario where you have two equations with the same slope and different y-intercept. And when this happens, there is no solution. And in a lot of homework systems and even in textbooks, you'll see DNE, all capitals. That stands for does not exist. Because there is no point where the two graphs overlap each other.